Welcome to Rani Chemistry classes. In this video, I am going to discuss about the multiple choice questions from Chemical Kinetics Intermediate Second Year Chemistry textbook for intermediate public examinations and other competitive examinations. Subscribe this video if it is useful to you. First one, the unit of rate of a chemical reaction is generally expressed as. So the rate of a chemical reaction generally expressed as concentration second inverse. Concentration units are mole liter inverse and second inverse. Second one is mole liter inverse, third one is mole, fourth one is second inverse. So 1 is the correct one because concentration second inverse are the units. For concentration units are mole liter inverse. Second one, the instantaneous rate of a reaction can be determined by using first one average time, second one total time, third one slope of the concentration time curve, fourth one is product concentration and time. So the rate of reaction can be determined from the slope of the concentration and time curve. Okay, next. Third one, which of the following does not affect the rate of reaction? Which of the following does not affect the rate of reaction? First one temperature, second one catalyst, third one pressure, fourth one color of the reactants and products. So rate of reaction increases with increase of temperature. For every 10 degrees centigrade, rate of reaction increases 2 to 3 times. Catalyst can increase the rate of reaction. Pressure also has the effect on rate of reaction. So fourth one, the color of the reactants and products cannot affect the rate of reaction. So answer 4 is the correct one. Next, fourth one, the rate law for a given reaction is determined from balanced chemical equation, thermodynamic data, experimental data. Fourth one is catalyst used. So for this rate law, for example, rate equal to K into A square V power 1. Here the power of the concentration terms is determined experimentally. It is not theoretically. Okay. So in this rate law, the reaction is determined from experimental data. Here these powers are also determined only experimentally. It is not determined theoretically. Next, fifth one, molecularity of a reaction can be. Molecularity means the number of reacting species present in an elementary reaction. It can be never be 0. It is always an integer. It never be negative. It never be fractional. So option 2 is the correct one. Next, sixth one, what is the overall order of a reaction which has the rate expression rate equal to K A concentration of A square B power 1. Here order is the sum of the powers of the concentration of the reactants. Here A square that means 2 plus B power 1. So order is equal to 2 plus 1 equal to 3. 2 plus 1 equal to 3. Here order is 3. Next, radioactive decay is an example of which order kinetics? So radioactive decay is an example of first one 0, second one first 2, third one is second order, fourth one is third order. Radioactive decay is an example of first order reactions. These are the first order reactions. What is the slope of LNA versus T graph for first order reaction? For first order reaction, here it is minus K. It is minus K. A plot is drawn between ln A naught Here time on x-axis, time on x-axis, here ln a naught. This intercept is the ln a naught, where slope equal to minus k, where slope is equal to minus k for first order reaction. So 1 is the correct one. Next, ninth one, the unit of rate constant of a first order reaction is second inverse. For first order reaction, k is equal to 2.303 log R naught by initial concentration of the reactant by reactant at particular time. So this is 2.303 by T. 2.303 by T. Here concentration mole per liter will be cancelled. Time second. So units equal to second inverse. Second inverse is the units for first order reaction. The half-life of a first order reaction is given by T half is equal to 1 by K, T half equal to a initial concentration of the A naught by 2K, 0.693 by K, K by 0.693. This is the standard value. By substituting R value equal to R0 by 2 and T is equal to T half, we will get. So that is so T half equal to 0.693 by K. Next, 11th one, the hydrolysis of methyl acetate in aqueous acid is considered as pseudo first order reaction because here acetate plus water gives rise to acid plus alcohol. Here water is in excess quantity. Acid acts as a catalyst. Water is in large excess. Methyl acetate is in excess. Reaction occurs slowly. Here in this reaction water is present in large excess. So rate of reaction is independent on the concentration of the water. So it is pseudo first order reaction. Next, 12th one. With the rise in temperature by 10 degrees centigrade, rate constant of the reaction generally increases by 2 to 3 times. First one is decreases 2 or 3 times, remains same. Third one increases by 2 or 3 times, increases by 10 times. So the answer is increases by 2 or 3 times. Next, 13th one, which of the following represents Arrhenius equation? K equal to A by T, K equal to A plus epsilon A by RT, K equal to AE power minus epsilon A by RT, K is equal to ln A minus epsilon A. So this is the standard Arrhenius equation, that is K equal to AE power minus epsilon A by RT, where A is the Arrhenius factor, epsilon A is the activation energy, R is gas constant, T is the temperature. Next, 14th, catalyst increase the rate of reaction by decreasing the activation energy, increasing the temperature, increasing the activation energy, increasing the concentration. So catalyst increase the rate of reaction by decreasing the activation energy, Next, 15th one, identify the correct statement among the following. First one, a catalyst does not alter Gibbs energy. B, a catalyst does not change equilibrium constant. C, a catalyst can catalyze a non-spontaneous reaction. First one is A only, second one is A and B only, third one is B and C only, fourth one is A and C only. Here catalyst does not alter the Gibbs energy is the correct one. A catalyst does not change the equilibrium constant. It can increase the both forward and backward reaction and attains the equilibrium in short time. It cannot affect the equilibrium constant. So option 2 is the correct one. Subscribe this channel. Thank you.